Well, hello there. Let's jump right into this quick video we have. It's the last video of the week. We've been talking about double inverses this week. And reminder, double inverses, the big picture idea was that if you have two repeated inverses of the same thing, you'll get back what you started with, right? So we then looked specifically at it through like a mathematical lens, and we wanted to see this idea that you can simplify an expression, something like 14 minus negative 3x, using this double inverse idea, right? So we would say, oh, I'm going to inverse the operation. I'm going to inverse the second value tied to the operation. And in this case, we would get something like this, 14 plus 3x. So the inverse of subtraction was addition, and the additive inverse of negative 3x was 3x. And this is a way we can simplify something without changing the value to write it in a better way. And maybe you're like, like whatever. That makes perfect sense. But the cool thing about the learning this way is that we can apply it to other situations. Maybe something like this: 4 divided by 1/2. Now, 4 divided by 1/2, I'm just going to jump right into it. I'm going to use a double inverse. So I'm going to find the inverse operation of division, and I'm going to find the multiplicative inverse of 1/2. Let's see, inverse operation, multiplicative inverse. So what does that give us? I still have a 4 here. The inverse operation of division is multiplication. That's nice and easy. And the multiplicative inverse, or the reciprocal of 1/2, is 2 over 1, which is just 2. So this is just 4 times 2, which is 8. This is just 8. 4 divided by 1/2, which is a kind of a crazy looking expression right there, is just equal to 8. Okay? Now, two things to note. One, we could have written this as 4 divided by 1/2. We like the division bar that way, but it's a little weird to have this like division bar with a fraction underneath it, but that is possible. And another thing to note is that we could have actually solved or simplified this expression using a number line. We could have said, oh, so I'm going to like have a number line here, and I'm going to break my number line up into like half-sized pieces, and I can count them, and you could get 8 this way, right? So maybe you're like, why do I even need to do this double inverse thing if I could just do counting like that? The double inverse thing works really well even when we have difficult looking expressions like this: 6x divided by 2 over x. Now I'm going to go out on a limb and say that we're not going to be doing a number line way of finding this thing. We're just going to have to use double inverses. So we're going to find the inverse of that operation. We're going to find the multiplicative inverse of this number. And we end up with 6x times x over 2. Now, this 6x is 6 over 1. If you've forgotten how to multiply fractions, you kind of multiply top to top and bottom to bottom. We end up with 6x squared over 2, which simplifies to 3x squared, right? The 6 divides by the 2, we get 3x squared. Now, this is not a super nice expression, but notice how it's doable with double inverses. I would argue if you're just looking at it from this way up here with dividing by a fraction, we're just going to be in a bad place. Okay, so double inverses works with addition and subtraction. With the additive inverse, it also works with multiplication and division with the multiplicative inverse. That's all I got. Peace.